Well, this is a quick test, kind of a cool one, of some objects that I found metal detecting. 20 euro coin, Canadian dime, gold bar, uh, men's wedding ring, gold band, and some silver nuggets. All of these are at room temperature, but the first test is with a magnet, and as expected, silver is not magnetic. The gold is not magnetic. The euro coin, not magnetic, but this dime sure was. And that gold bar, which is the indication that gold bar is junk. So, and actually reading what it says on it, it's 0.999% gold plated. So the interior of that is steel. So one of the things we know about these metals is the Canadian dime is actually 100% nickel because it's a 1985. Between 1968 and 1999, they were made with nickel. 2000 onwards, they're made with steel. The euro coin, that is made from what's called Nordic gold. That is 89% copper, 5% aluminum, 5% zinc, 1% tin, and no gold. So the next test is the ice cube test. The theory here is that silver will transfer its heat into the ice cube and melt the ice cube faster than the other metals. So let's try it out. If I stick the gold ring on it, this is 14 karat. So the 14 karat will be mixed when it's a yellow gold like this with a reddish tinge, probably copper and silver. And it is melting the ice cube. Sometimes it's difficult to see exactly how much melt is going on and how long the reaction occurs, but what we will see is that it has buried itself, sticky a little bit, it has buried itself a little bit in the ice cube, but not much. The reaction, but is slowing down. The ring itself is cold, but not, I wouldn't call it ice cold. Let's try the euro coin, the Nordic gold. Again, a melt starts, and I can actually hear the ice cube melting a little bit. It's kind of squeaking, and it is causing some kind of reaction, but I wouldn't say a quick reaction. Let's just see here, and it did flatten the ice cube out a bit. It is quite cold. At the same time, this little nugget here had about the same weight as the euro. It tested at 90% silver and with an acid test. So let's try it on the ice cube and see what happens. Okay, go. And wow, I can see the water is developing around the bottom, and it did move a little bit on the top. I believe it's melting itself into the ice cube. I'll give it another second or two. And it was stuck a little bit, and it has certainly flattened out that top of the ice cube. And it is, I can tell it's much colder than the coin got. Another nugget, this one has some silver. The rest of it is, so the silver, if you can see it, is quite shiny. And the duller gray is cobalt. Let's try it. Give it a second here. Not a fabulous reaction. I don't know the percentage mix. When I did the acid test on the silver itself, it came up at 80%, but the other parts have some silver in them, but not a lot. And so it truly is a mixed ore. But it did sink itself into the ice, and it left a pretty good indent. And it is ice cold, so maybe the silver content's better than I'd figured. Going with the bigger nugget. Just tested at 80% silver. Good reaction happening. That's why the ice cube is sliding around. It's creating a lot of water. We'll give it just give it a quick time on the ice. And oh yeah, it's melted quite a bit of the ice now, and it is dead cold. Don't think I've done the dime yet. Let's try it out. And it starts an initial reaction, and it looks like it has stopped. I'll give it another, to be fair, I'll give it another couple of seconds here. It has melted some ice, and it has buried itself into the ice, and it was sticky. You can actually see the outline where the dime was. So that's not the reaction that one would want to be a definitive test. Let's try one last thing. This is, yep, it's causing a melt. Squaring off the ice cube a little bit. So, here's my opinion. The ice test is fun to do, it's interesting, but it's not definitive.